Hello guys, I hope you are doing well. So I'm bringing this tutorial because some of you have asked about the byte enable and the way to check the memory content without the solution. So I'm here bringing something that could be useful for you, and I hope you can use it for clearing ideas and doing your lab, right? So what I have here is the template, which I have modified, and I have it here. And I just erase everything except for Flash instantiation, right? And I wrote a special, like very simple kind of memory reading, right? So if you see here, I just set to the byte enable 4 bits to 1, right? And I'm using the switch from 0 to 9 to address the memory. Then I'm using the key 2, right, to read the memory from that location. And I have here the output of the memory and the read valid data, right? So what I have here is a simple register which works with the 50 megahertz, and every 50 megahertz, as long as the flash memory read valid data is enabled into a register, is going to be stored the flash memory read data, right? Otherwise the data remains the same. So for having like a debug tool, yeah, in the real environment, you can just bring the data to the bits, right, and multiplex that data with the keys. So I can see the less significant byte to the most significant byte. So, but you were asking, hey, but how do I know I'm doing well, right? So because you don't know the content of the data, right? So in the files I'm going to give you, I have converted the file, the jig file that you have that you actually program on the D1. In this case, it's for the D1, but it's completely the same for the other memory, for the other sorry, the other board. So I converted the file to a binary file, which you can open using this tool HXD. So you just have to open it here, and you will see all the content of the memory. So here you have the first 32 bits, the first byte, and the first word of the memory. So what I want to show you is that actually you can, in base of that, you can compare if you are reading the memory properly with your code, right? Using your code. In this case, I'm giving you like a template for reading that. And I have here, so you must have the memory program, right? So you have to write the flash memory before with the gig file as the lab shows you. So I already have that. But after that, you have to compile this, right? And program the FPGA. So I have here the programmer, right? So I will program the FPGA. Okay, I have other thing working now. I will stop it. Okay, let's start. I will program the solution, in this case that small solution, and I have here also a signal tab. So I have modified the signal tab that you had for the lab one, which had the LCD scope, right? But now I just have the data. Which data? The data, this data, the register data, right? So every time I'm pressing the key button and changing the switches, I can see the result and the output data from the memory, right? So I will run this, and you will see here the data, right? So in that case, it starts with obviously 0 because I haven't pressed the board, but I will set the keys to 0. So all the keys from 0 to 9 are going to be set to 0. And now I will press the key 2. So what I have done here is like I have to set the address I want to read, and then I can press the button, right? So I will press the button 2 to see what happens, and I see here a number, right? So I'm going to show you here. So I will magnify here. Maybe it's better, right? And I will show you that actually you can double check your readings with your hardware, which in this way. So I hope I can see it. So I will. Okay, exactly. I have here. So that's the value you're reading now. So it's FA030504, right? So let's compare that with the X tool. So I have here the X tool. I will put it here on the other side. Then the number, right? The signal tab. So what I have here is the most significant byte. It's actually FE, right? Then the middle byte is 0 or 03. The next is 05 and 04. So what happens if I want to read the positions, the second position of the memory, right? So this should happen, right? I must, the signal type must show that in the most significant bit for the second address, right, the most significant would be FO, right? So I will change the address using the keys, the switches, sorry, and then I will press again key 2. So I will change the switches to 1, and then I will press 1, the key 2. And what I see here is actually F0, F1, F2, F7, right? So, and you can go like do this and repeat this and every time you want just to verify. And if you are lost, I guess this is a really good thing for you, because actually you can verify that what you're doing is okay, right? So whether what you are doing is okay or not, right? So this is like a little help I want to give you, everybody. I will post this on the Piazza right now, and I hope you can work with that. And if you have more doubts about it, so let me know. I will reserve some time for you, dedicate some time for you if you want. But I guess with this you can start, and I hope all the doubts are clear now.